All right. So today we're going to talk a little bit about Shoodly. So and migration too. So Shoodly is an assertion library. I prefer it because because I don't like the word assert. Like, have a think about it. When in your day to day do you use the word assert when you're not talking about unit testing, right? I prefer that my code reads more like the language that I speak. The if your code reads like this, then it's easier for people to understand, especially people that don't come from a coding background. It takes out the lexicon that you need, or the jargon, or the glossary to translate tech to normal people. And I believe this reduces the barrier for people to get into coding. So the problem, though, is that if I want to migrate to a new assertion library, I've got a lot of existing code that is already using asserts. And it's a big job to go through and nitpick out all of these things and move them. So you may be thinking, oh, let's just use AI for that. Well, you can. AI, though, for me, it's not consistent. And there's a way that you can use AI to make it consistent through static code analysis and code fixes, which is what we're going to look at today. So you can see here that this is how your traditional assert works. Assert that blah blah is equal to something, and this is how Shoodly works. So it's an extension method that goes on the end, and then it says should be or should something, and it's a little bit more readable. So it's a pretty easy change to go from this to this. So that's what we're going to look at today. So to do this, what we need to do in C# is called Roslyn code fix. So you may have seen these little squiggly lines in your IDE, and getting prompts, especially if you're using ReSharper, which you should be, to automatically refactor things. So this is something that you can write code for yourself, and not only can you detect problems with static code analysis, but you can fix them as well. The way this works is pretty much all languages use an AST, an abstract syntax tree, to map the code. And that's how your IDE views your code. Your IDE doesn't view your code as a bunch of text. It views your code as an interlinked map of different things that are interconnected. Now I'm going to show you LinkPad, and just some stuff in here. So if we have a look in LinkPad, I think has got an excellent viewer for the AST. So we can see a bunch of code here, and then you can see here down here in the tree view, we can see the full AST, and you can click on things to start to inspect it. So you can see things here, they're like trivia. This is what's used for white space and comments. There's things like the main function there, the parameter list for the function, and things like this. So this is how you query into the code using the AST. I think it's a good visual representation. So what we're going to do today is we're going to write some code, and these static code analysis rules with Roslyn and the code fixes, they're all written in C# as well. So we can write code that'll go and inspect our code and also mutate the AST and fix the code. So let's go back to look at some code. So I've already started work on this project. So there's two parts, like I was saying. There's a static code analysis rule. So for that, we inherit from this diagnostic analyzer. And here we put in a bunch of metadata, such as the diagnostic ID that'll come up in the IDE, whether it's a warning, info, error, compile error, message, the title, the message, category, things like that. And then there's a little bit of boilerplate that we've got to add in. And then this analyze node method is what's passed into the register syntax node action method. And then that is basically where all the magic happens. So in here, we inspect the AST, and if we find things, so in this example, I'm looking for something that's assert that, then we can report, call the report diagnostic method, and create the diagnostic around the location, and there we pass in the rule we've created, and that then bubbles up with to the IDE or the compiler, with the information to display and the position, to highlight that particular analysis error or warning or info or whatever level we set. And then the other part to it is the code fix. So this is a separate class that we create called a code fix provider. Now, you can have analysis that doesn't have a fix. Sometimes you may just want to warn or give people information, and there may not be a definitive way to fix it or whether you should fix it at all. So sometimes you just create the diagnostic analyzers and not a code fix. But in our case today, what we're going to do is actually create a code fix. So I've already started work on one here. You can see it looks similar. Again, we've got a bunch of boilerplate. You link it back to fixable diagnostic IDs. So through the diagnostic ID that you created in the diagnostic analyzer, you can link this back to it. And what this allows the IDE to do is when it gets bubbled up the information that we bubbled up before about, hey, this is some metadata, this is the location of code, it also can see which code fix providers it can then prompt the user to action that warning or error with, to take some action in the IDE. And you can see here it's pretty similar. So we've got some boilerplate code at the top, and then we've got a convert to shouldly method, which is passed into the code action create method. And this is where all the magic happens. Essentially, from here we get a location in the code, and then from that we can manipulate the AST tree, which is what we're doing here, in order to change the code and then return a changed document back with the changes, and then the IDE will use that to apply the changes to the code. But that looks like a lot of code to write. So, maybe I've got a few hundred or 1,000 unit tests in my project. Now I've got to go and figure out these Roslyn APIs, and that's going to take me time. And so maybe it might be just worth it because it is repetitive code. Maybe I can just Control-Shift-H most of it, So this is where AI comes in and where I've been using it lately that I wanted to share. So I've been using AI a lot lately to write the automation that changes the code as opposed to using AI to change the code itself, which makes it a lot more predictable. So I've been using Claude a lot. So we're going to start a new chat with Claude. And one of the ways that I like to work with this stuff is by creating the tests first, kind of doing TDD with AI. So we're going to start with just getting Claude to tell us all the examples that we need to create tests. So give me a list of all the versions and let's see what Claude comes back with. So, after a bit of back and forth with Claude, I went to ask it for the examples, and then after asking it for the examples, it gave me some back in Markdown, which I added to the test, just so I've got some issues. So I've just got some documentation in GitHub. And then I actually asked it I gave it one of my test cases and asked it, look, can you grab this? Can you pull out the pieces that we need to change for each test? And then create test cases for each scenario that we need for the conversion. And it's come back and it's kind of done that, which is good. So, but it's put a test case source here. and then created a private static method to get the test cases that we need. Then it's bombed out here and said add more test cases for other assertion methods. This is because with the current models that we're using, they've got a lot more input tokens than output tokens. So you're going to see this when you're working with AI, is it can't write a huge amount of code. It's limited to about 4,000, 8,000 tokens, depending on the model you're using. So then I asked it for, can you complete this for me? But I mentioned only. Otherwise, it gets a bit too wordy, and you probably get too much output again. And it tries. Sometimes I've seen it try to, when I ask it to complete something, give me all the code again, and then try and complete it, and it just gets into a mess. So it's important to include that only word I've found. And then now what it's done is it's given me just the private method again with a complete set of test cases. So now I've got my failing test. Asked it for a revision, and this is actually, I've hit the limit. So I'm going to try and ask it to response. Right, see if it'll finish it off. Looking good. So I've had a few rounds with Claude. I had to fix up a few minor things. Most commonly, though, what it got wrong was the line number was just a little bit out, or the start column, or the end column sometimes. So that was pretty easy to fix. Now, what it looks like is I've got 6 passing tests because some of it was already written into the library. We've done some basic work, but we've got 32 failing tests in total, which is what we're after. So now we've got a lot of failing tests, and they're failing with things like, something was done, but it wasn't what I expected. In some cases, it looks like there's an actual bug, which I noticed while I was using the library my IDE the other day. So it's good we'll be able to fix it. Here's another one where it's slightly off. This is a good example. Does end with 63. Again, and then end with expected 63, actual 59. But we just updated that. There we go. And now it's yep. So this means that it's not expected. So that's a proper failing test. That's what we want. So now what we can do is we can go through and implement the code to catch all of these. Now I'm going to ask Claude to create the analyzer and the code fix. Something I've noticed with Roslyn, though, is that the LLMs are trained on all the code on the internet, and there's heaps of Roslyn code on the internet, and there's 4 major versions of the API. So if you don't specify your API version, it actually writes some analyzers that use versions of 3 that have been deprecated or 2. So you have to ask it for which version to be compatible with to get the best result. So let's see what it comes back with. So we can see what he's come back with here is a diagnoser, an analyzer, and a code fix. The analyzer is quite easy because it's just looking for assert, collection assert, or string assert. The code fix, though, is a little bit more complex. So there's a lot of cases that it's got to fix. And that's where it's bombed out and said, I don't have enough in my output. So what we can do is here, please give me the and we should get the rest of the code we need. And then we've hit Claude's limit again. So we should be able to just go was a lot of code. So it's not perfect, but we're getting there. It missed a couple in the output. A good example was the R equal and not equal. The other thing it missed was white space as well. So it was removing the leading white space, which is making the test fail because the test looks for the white space as well. It's not good when you've got to keep the white space in there. Otherwise, what will happen is when people refactor and use the code fix in their IDE, the code jumps around everywhere. And it's horrible. You can rely on your IDE to auto fix, but it's better to just use these with leading trivia, things like that. It was pretty easy just to add this extra line in. And now it's just a process of going through. I've got these two passing. What's wrong with the next one? Again, we're getting problems with these. The location is slightly off with some of them. So if that's not correct, it won't actually test the code fix. Now I've corrected that. Let's run it again. All right. And now, yeah, so it's the same thing. It's missing the leading white space. I think it's going to be a common problem. So which one is that? Let's again. Pass. And so it's just a matter of going and pressing repeat for the rest of them. We have 38 passing tests. Now, if we have a look, these are all the test cases. There's a lot of them. And the code that it's generated is a giant switch case statement, which is just horrible. So there is a lot better ways to do this. But that's the key thing here. We're doing TDD. So we have a passing test. We know that this code works and is valid. So now we can work to refactor this. But before we do, I'm going to try it out in some production code. So I'm going to talk a little bit more about the project itself before we look at applying it to some code. So there's a VSIX project in the solution, and this is what you use to debug the project if you want to test it out in your local. And what that'll do is if you kick it off, you've got to set that as a startup project. It'll start an experimental copy of Visual Studio, which will allow you to debug. So from within here you can open other projects that have code in them that will get triggered by your analyzer, and you can set debug breakpoints in your other copy of Visual Studio that's open, and step debug into your analyzer code. So this is just the basic class that we've got. It's got a couple of lines that'll trigger our analyzer. So what I can do, that works. I need to set a breakpoint for over one of these that's meant to trigger it. Bulb, straight away, bang, it goes off. The reason that it's doing this is because what usually displays here is a preview window, and it actually has to run the code fix on a essentially virtual copy of the code to give you a preview of what it's going to look like. So that little tooltip will just stay up there, and I can step debug through my analyzer and have a look at what's going on. This is a little bit slow. I wouldn't recommend opening like a big project. That's why I've got just a project in the background there with single class in it. So this is an example of a pretty decent sized code base that we can try this on and see how it looks like. So you can see here I'm getting the tooltips coming up. They look a bit different to the experimental version of Visual Studio because I'm running ReSharper here. So I can click on that. You can see here's the preview window that comes up, and we've got the convert to shouldly here. It shows me what the code will look like. But it's also got these options down the bottom. I can do it in document, project, solution, or whatever. When I've done these before, sometimes there's bugs, and it's hard to pick up until you run it on production code, which is why I wanted to give this a go. But what I generally do is try it at like the document or project level. If it fails at the solution level for some bug, and then try and find out where that is, and then use that as a piece of test code that we can then feed into the tests and improve the code fix. So I'm going to try it on the project level, see if we get lucky. See, there are lots and lots of code is getting changed here. So I can click apply, and it's done. Now I do have these here because this is just means the import needs to be added, and then it's cool. And then it goes through. There's quite a few imports missing. I have done putting the import in as a part of the code fix before, but I had problems with doing multiple document changes in one code fix, and never got it quite working. But that's just another step you can just do on the end with the imports, and now it's gone and fixed everything. So that was probably about 600 code changes, I think, in one go. It's pretty powerful stuff. After a bit of cleaning up, it's building. No errors. There was one issue that I found that I logged. Pretty minor one. It just seems to be missing some brackets that it needs around some of the is true, which is pretty impressive considering how many it updated that we only found one issue. And that's it. So what we're going to do now that we've tried it out in production is have a look at how we can address some of the pretty ugly code that we had, those huge methods and case statements. So the first thing to do with really long methods like this is look how we can break out similar functionality and group it into private methods. And then once stuff's grouped in there, you can look at further refactoring it. But usually the first step is breaking things into private methods. So you can kind of group the domain of what you're working on or the functionality into things that may have things in common. So one of the things that we can see here with these switch statements is the collection asserts and the string asserts seem to be a group that we can easily pull out. So what we can potentially do is something like this. So I can go if the assert class is collection assert, then we can call another method, a private method, and put them in there. So I'm going to call this collection asserts. Now that method doesn't exist yet. That's on purpose. And what we're going to need for that is the method name. And also there's the invocation that's used. So it's used in a couple of places, and that's where it gets the argument from. Okay. So now my IDE can create that method for me. Okay. Then what I can do is I can grab all of these collection asserts part of the switch statement. pop them in here. Our argument's going to complain. That's why we have to this one. You could also pass argument in as another method, as another parameter too. And this is going to complain because it's returning void. And now the assert class piece we have to remove. Should be able to pop that out like that. Now, return null in the case it isn't handled. And then that's done. Go back up here. Now, this is probably going to be a bit ugly, but collection handled that. So if this is null, it hasn't been handled, and we have to continue. So what we want to say is if return handled, there we go. So that's grabbed a whole bunch of that switch statement and put it in its own private method now. And let's see what happens when we run our tests. All good. So that's why I wanted to get the test coverage first. Even if the code's ugly, we've got passing tests. We can now really play around with the code, start to refactor it. Now that I've got all those collection asserts in one area of the code, there's probably some commonality in what's going on with them, but they're in a nice method now, so we can start to play around with that, look for reuse, and potentially even start breaking out from those private methods. They'll still be quite large too. We may be able to break them into their own objects or processes or things like that. But the whole time we'll know whatever we're doing, we've got the test. It'll tell us if we've broken something, and it'll keep us honest. So that was converting a project to shouldly. One of the big points though was less about shouldly and more about doing these migrations. I think that the tool chain that we have in the Roslyn analysers, and it's also in pretty much every language, has got similar tooling. Pretty much every language interprets its code with an AST tree. A lot of them have very good APIs for querying this, mutating it. Ones like the TypeScript and JavaScript ones are also very easy to use. The C# ones have got a bit more boilerplate than others. I don't mind it though, because it essentially gives you more metadata that you can put in there. I think one of the things that I like about the .NET version is that you can put URL links into there to documentation. One of the problems that I find with linters is sometimes they're just these annoying little messages and you don't understand them. And to be able to attach them and link them to something that goes, hey, this is why this is bad, helps to make them less of a tool of annoying or blocking and more of a tool of education, which I think is really important. This library is available if you want to migrate a project to shouldly. Also, we did another library at Agoda that we maintain that we did years ago, and it's still up there, where we took a lot of our internal opinionated standards on full stack development and put them into a library that we open sourced and made public. So I'd recommend checking out that as well if you're interested in this. It's a similar way of working with what I was showing today with the shouldly from assert library, except it's a different focus. For me, I think these metaprogramming tools are amazing. One of the things that's always been hard for me about them is remembering the APIs, because you don't do them every day. But I think that's one of the powerful things about AI is it's got that vast array of knowledge. So it really helps with these engineering tasks that are the things you don't do very often, and it's easy to forget some of the context and the APIs and things. So that's it. I hope you liked it, the video today, and thanks for watching.